Okay, new video type to hopefully be able to do the graphing a little bit nicer here. So imagine that we wanted to transform a graph by either stretching or compressing it by some factor. We could do this in four major types of ways. So let's set ourselves up with some target points. So that way we can see what it'll look like under these transformations. So let's take our target points as -2, 4, and let's go with 1, 2, and go with 2, 4. So these will be our target points that we're going to transform. And the reason I chose those points is because over here in the background I have a graph that is drawn that has those points on it. Yeah, in the form of a triangle here because it connects the lines automatically, but the function would probably be from -2, 4 to 1, 2 to 2, 4 in most of the applications that you'll see. This extra line wouldn't be drawn, but it's kind of cool to see how this will change in the effect when we see the transformations. So we have those target points. Now let's look first at type 1. Type 1 would be what we call a vertical compression. And a vertical compression algebraically is going to be a function like 1/2 f of x. So it's going to take all of the values of the function and then half the y coordinate. So what is it going to do to the point -2, 4? Well, -2, 4 is going to be sent to something that has half the y coordinate, but the x coordinate remains the same. So the x coordinate is still -2, but the y coordinate is halved, and so it becomes a 2. And what happens to the next coordinate? What happens to 1, 2? Well, 1, 2 is going to be sent to something that keeps the same x, but halves the y, takes half of the y. So half of 2 is 1. And finally, what's going to happen to the point 2, 4? Well, yet again, the x coordinate is going to stay the same, but the y coordinate is going to be halved, and half of 4 is 2. So the new points are going to become -2, 2, 1, 1, and 2, 2. -2, 2, 1, 1, and 2, 2. So if we move over here and plot those points, by the way, this graphing utility is from mathisfun.com, just for an appropriate reference here. So we're going to graph -2, 2, and then we're going to graph the point 1, 1, and the point 2, 2. And notice that on the right hand side the graph was shrunk or brought down vertically by a factor of 2. This point got shifted down to here, this point got shifted down to here, and then this point got shifted down to here. So it became half as tall. So let me remove these points so that way when we come back and do this again they won't be on there. Okay, so there's 4 different types. We'll do 2 types just mentioning them, and then I'll use the graphing utility for the 4th type again so we get to see them all. So after vertical compression, the next logical one might be to do a vertical stretch factor. And the vertical stretch factor will have an algebraic equation that looks like 2 times f of x. And the way that this is going to occur is by taking the original point, -2, 4. It's a vertical stretching factor, so the x is going to remain the same. The x coordinate is still -2, but we double the y coordinate, which would be 8. And the next point, 1, 2, again the x coordinate remains the same, but the y coordinate doubles, so the 2 is going to double to a 4. And finally, 2, 4 is going to be transformed by taking the x, keeping it the same, and doubling the y value. So that would be 2, 8. Okay, we've completed the vertical types. Now let's look at type 3, which would be a horizontal type transformation. And let's first do a horizontal compression factor. Keep in the same order, right? We did vertical compression, vertical stretch, now horizontal compression. Now horizontal compression has a form of F times 2 of x. So putting 2 times the x coordinate compresses things horizontally. Note well that 2 outside is a stretching factor vertically, but 2 inside is a compression factor horizontally. Now, -2, 4, we are now compressing horizontally, so the y coordinate is going to stay the same, but the x coordinate is going to be halved because it's compressed. So -2, half of -2 is -1. I know this feels kind of weird in the sense that the other one, 1/2, you just multiplied the value by 1/2 or halved it, but here the 2 causes a halving on the x. And you might be able to guess now what's going to happen to the point 1, 2. Well, again, the y coordinate is going to remain the same, but the x coordinate is going to get halved, so that would be half of 1 is 1/2, and there's our coordinates, 1/2, 2. And finally, the last point was 2, 4, and if we compress that horizontally, again keep the y coordinate the same, and half of 2 is 1. So that's the end of that one. Looks like I have an extra parenthesis there. There we go. Okay, last type, in type 4 we'll go over and look at our graphing utility again, is horizontal stretching factor. And the horizontal stretching factor general form would be f of 1/2 of x, and the 1/2 here would be a horizontal stretching factor. And so what's going to happen to our points? -2, 4 will be sent to 4 remains the same. It's not a vertical effector, so it doesn't hit the 4, but the -2 is going to now be doubled. Double of -2 is -4. And 1, 2 will be horizontally stretched, so 2 is still the y coordinate, but the x coordinate becomes doubled. So 1 doubled is 2. And finally, our last coordinate was 2, 4. And in this last coordinate, again, the y will remain the same, but our x coordinate is going to be doubled in size up to 4, 4. So we'll have to do the points -4, 4, 2, 2, 4, 4. Come over to our graph. We have the points -4, 4, then 2, 2, and then 4, 4. And notice that this took the point at -2, 4 and stretched it left. It took the point at 2, 4 and stretched it right. And it took the point at 1, 2 and stretched it to the right. So things on the right get stretched, things on the left get stretched, and it's like taking both sides and pulling it out.